What's going on, Eric? All
A little
right.
overwhelmed with the math here. I'm gonna have to go back a few weeks and try and look at the
Oh yeah. We're gonna
stuff.
make sure I'm gonna make sure everybody gets it done. I'll put a help session together probably.
Okay.
Um, what I think I'm gonna be my wife and I are headed off to Fort Myers Beach tomorrow for,
Lucky you.
for a little vacation because we she referees college lacrosse. I do football. So
Yep.
we have a very small window to actually vacation together.
Yeah.
So we're gonna go tomorrow. And I didn't go down last year because the hurricane wiped out a lot of the West Coast, so I'm gonna get the
Yeah.
Wi-Fi set up on Monday, and once I know that, then we can plan. Um, just got to do 2 weeks of control after today, and then the help session, and I want to start putting together some project teams. We're just basically just pick some data, working together with other people, and collect some data and just make it talk. That's all. That's really all it is. And I'm going to send you some examples of some of the final exams from the past. So I'm just in the process now of just starting to put together like teams, try to balance them out, that kind of thing. I want to give the MVP to Dan Rakowski because I think he did the homework on Christmas Eve, maybe. Right, Dan? I was like, really, as soon as I sent it, it was back.
No, not Christmas Eve, but it was definitely the next morning, I
Yeah,
think.
at the Albert Christmas party, I think you did it. All right, so without further ado, let me go right into. So I'm gonna try to catch up a little bit, like because it was really disjointed, with the holidays and all. So I'll start with math practice. Let me actually start with our progress, and don't get too fired up about where the status is. I have it. This is what I have it, and my goal is to try to get everybody, to try to get through and do those little exercises. And if need be, I'll do a help session, to get everybody through it. I think it's important just to try it. So this is what I have so far. I have Dan, Matt Schwartz is on, and Ty are the ones that I have, I think, everything for. So, everyone else, I know Jeff Hines from PTA in Oxford got moved to, I think he's on a third shift again. So it's a little tougher, so I definitely got to circle back with him. But again, no biggie. I just, part of what I do is just I'm going to work hard to try to make sure that everybody gets at least a little bit of practice in mastering these simple tools. And they're not that simple if you don't use Excel all the time. So it's just a
Yeah,
matter
I
of just
don't use Excel.
practice.
I've got very little experience with it.
All right. So with that said, let's mute everyone, and I'll have at it. All right. So this week, I mean, really cool. I think I told you guys my favorite tool by far is correlation. Because basically, the homework was, is there any statistical correlation between my weight and my pulse rate? Like, in other words, when my weight goes up, does my heart have to work harder by measuring a higher pulse rate? And I just love it because, and we put this in the improve phase because you could think about like, temperature and pressure or, things that you can control on a machine, for example. If I change this one dial movement, can I predict what's going to happen? And that's kind of what it is once my process is stable, and I think my weight is a better example than these only 10 examples here of age versus salary. And I just use this one because I think it's easy to show the tools. But to just review, there was this correlation, this R coefficient. Largely if it's zero, that means there's no correlation between them at all. If it's between 0 and +1, it means there's a positive correlation. The closer to 1 it is, means it's a very strong positive correlation. And the closer to -1 it is, I could have a very strong negative correlation. So in this example, let's say at age 18, my salary is $40,000, and then at age 40, it goes down by 20,000. Well, that would be a negative. So in other words, age goes up, salary goes down, right? Or if my weight went up and pulse went down, or vice versa. So basically, we're looking at very strong or weak positive or negative correlations. And in this case, when the slope of the line is on a salary is this strong, going north like this, and all the data points are kind of laying along those lines. We have a pretty strong positive correlation between age and salary. And we prove it out, by using that function. A scatter diagram is one way, which I think most, people that handed homework in, they did that already with my weight data and pulse. The second way is using the Corel function, equals Corel, and just highlight age and salary. And then the data analysis pack, you get out this little thing down here which says column 1 and column 2. And then if I did this formula, if I had another week's vacation and I didn't have nothing to do, I'd go ahead and plug everything in here, and I'd get pretty much close to the same thing. Today, what we're going to talk about is this is like my favorite part of this whole class, believe it or not. I mean, and some people like other things, like I just love this, because it just makes so much sense to me. What we're going to talk about today is regression and residuals, right? And all the regression is if I want to be able to predict, let's say I put in age, I don't know, say 55 here or 51 or something like that here, right? I can almost predict what my salary is going to be at 51 based on this data, right? Based on this data set here. And the way I would do that, and also if I have a bunch of data, how do I draw the line? Like what's the way to draw the line? So I'm just going to show you a quick, this is the homework today. It's to do exactly what I'm going to do, except for the weight and the pulse data. And so all I do is I right click on the line, and it's going to say format trend line down here again. This is like the quickest homework of the day, of the year. All I'm going to say is display the R squared on the chart and display the equation. And you can see there, nice and neat and clean, they got displayed on the chart. So there's two things that I'm interested in order to be able to draw a line. All right, and be able to use that line to make predictions in terms of how are my improvements going to impact my process. And the formula is y is equal to constant 1320, not a constant. This is going to be something, the slope. This is the slope of the line, and that's what's the rise over run. What is the slope? What angle is this thing increasing at? Times, so y times the slope. Let me just close that up. So y is the slope, and then what the next thing I need is what is the y-intercept? In other words, where does this line cross? The y-intercept is on the left from $1,000 to $90,000 here. Where will it cross? If I continue it down, at what point does it cross? And in this case, it's minus 6627.7, right? And the way I can get those numbers is, again, I just displayed those numbers just by using, just by using the scatter diagram and saying, show me the formula. But you can actually use in Excel equals the slope. There it is. And then it says known y's and known x's. So I grab the y's first, highlight them. So this is what you'll be doing with the weight and the pulse, and then comma, and the known x's. And then hit enter. And I got 1320.5, just like, so that's the slope of the line. And then the intercept, where does it intercept with y? It better be 6627.7, and that's equal to the intercept. There it is, the function, known y's, comma, known x's. And you'll be able to do this just by highlighting the whole cell. You could also get it a third way. Let me get rid of this dialog box. If we go into data analysis pack, and there's a couple of tools down here. Regression is the one we want. Regression, hit OK. And this is wicked cool, because now what residuals are is it's actually measuring the variation from this trend line. right? So it looks at every single data point, and it actually does analysis of variation, ANOVA. Remember that it's variation within and variation between groups. It does that with all this data, all right? So I'm going to go ahead and check, show me the residuals, and I'll do standardized residuals in the input range Y. These are my salaries, my input range X. There's my age. And on confidence level, because again, remember, those were hypothesis tests, ANOVA. So I want to know 95% confidence, what are my residuals? And all they are, again, guys, is the distance from that dotted blue line. So obviously, the closer to zero my residuals are, means I have very or little no variation in my process. Hit OK. And oh boy, what it pop up? Okay, I'm on another sheet. So this is what it looks like. So you can put it on another sheet, or you can put it on the put a place up for for that sheet. But if you see, here's the 10 observations, and here's our predicted Y, and this is how far off they are, and here's our residuals. And that's all it is. It's all and also when I do the data pack, here's my y-intercept. Here's my rise over run 1320. There's a whole bunch of other stuff here that we may not use, but here's R squared. There's a very strong positive correlation between age and salary. But I thought I want to. So the homework will be do kind of the same thing we did last time, except using those things, these tools, to get use the line graph, get the formula on there, use the Excel functions, and then you go ahead and try to data pack and just take a peek at it. And I don't think there's anything on the exam on that, but I think it's my favorite tool. There must be something wrong with me, right? So I think, any questions in terms of the homework, or it's just basically we're looking at regression, which is, all right, how do I draw, where would I draw a line here? What's the formula for that line? Now I could plug in any X, right? I can go 1320.5 times 55 years old minus the y-intercept, 6,627, and I'm going to get a Y. I'm going to get a salary. And then now when I look at residuals using this model, how far is it actually? So, so then you measure and say, all right, someone is that age, how much are they making, and how far off are we? Does everybody get that? Understand the value of this? Has anybody done it in the past?
Using Minitab.
Okay, yes. Okay, that makes sense. Yep. And all right, so I'm going to stop sharing this. I'm going to hop right into, we're going to shift gears a little bit and head into the PowerPoint. And I'm going to start at root cause. I'm just touching real quickly on what the improve phase entails. Is selecting improvements. So that was on the last session. I think I covered that okay. And then I'm not sure that root cause is on there, so I want to just cover it. And we usually talk about 5Y, but I think this is a good opportunity to talk about fishbone, a cause and effect diagram. And again, like all of our Lean and Six Sigma tools, these are not to be done by yourself. They're much better, much more effective when you have a 3 to 5 person A3 team, or 3 to 5 people that can weigh in on it. Think about all the things we like, the affinity diagram. We can go on and on in terms of all the tools that are just so much more effective when we have a group. This is also called a Ishikawa diagram, and they call it fishbone because at the end of the day, it looks like a fish skeleton kind of, and it just shows relationships between effects and potential causes. That's all. And a lot of times people use what we call the P4ME. And those aren't set in stone. I think I have an example of how to use this tool, with no P4ME. But the potential categories, the ones that people use most often are, what are the causes maybe that are manpower type? What are method type, procedures, policies? How about the machine, and the equipment and tools needed to perform? So these are all variables that might have a cause. So we're trying to get to the root cause of a problem. And it's just a way to categorize each of these types of, these categories, possible root causes. Materials, looking at the lot numbers, or, what material, is it a change in vendor or whatever, maybe expired, who knows, material. Measurements, how we measuring the process. There might be some variation there. And then the surroundings, the environment. And the first step is identify, define the effect being analyzed. What's the problem that we're trying to understand the root cause of? And clearly state that. And that goes on the kind of the head of the fish. And then you brainstorm a bunch of those potential causes for that problem or the event occurring. And just brainstorm for a while, get a whole list of them, put them on sticky notes if you want, and then take them all and put them in one of those categories. And the categories P, 4, M, and E, you can have other ones too, as I'm going to show you in a second. And you put those sticky notes, where would they fall? Is it a person? I don't like to ever use, like, one of the things I want to make sure everybody understands is, in my career as a lean guy, if we're always doing 5 why, and the last why is we got to go talk to Joe, or we need to retrain Sue, or then I like to do fishbone then, because that'll get everybody's thinking off of people, right? Because the right process will produce the right result. It doesn't talk about the right person will produce the right result. People are smart and people care. And that's how we always have to think that way as continuous improvement people. And I love using fishbone if all of our 5 whys, the last why is, I know what happened. Dan Rakowski screwed up. Like, we don't want that. It's not about people, right? Sorry, Dan, I got to use you as an example, right? And basically, so you just take each of those categories and you put it along the fishbone. So you'd have measurements, and it would go right on that backbone of the fish. All right. Is there a metric issue? Is there a valid measurement system? Do we have enough data? Is the data available? Those all might be questions if we're trying to get to the root cause. Measurements might be one problem, that might get us to the root cause. Manpower, are people trained? Do they have the right skills? Is there enough people there? Does it vary by shift, the impact? Are people overworked? That kind of thing. Those are all possible. Who knows? And that's what the beauty of the brainstorming of it is. And then methods, how is it performed? Are the procedures correct? Does everybody do it the same way? Do we have standard work? That kind of thing. Those might be some effects that would cause, some of the cause, maybe root cause of the effect that we're after, the problem that we're trying to solve. And then materials, the bill of materials current? Are the parts or supplies obsolete? Are there defects in the materials? That kind of thing. And the environment might be, is the workplace safe and comfortable? Outside regulations impacting the business? Does the company culture help us or hurt us? Those types of things. And when you get all said and done, this is what it looks like. It looks like a fishbone, kind of. And again, the way you get really, really good at root cause, for those of you that want to do lean for a living at some point in your life, is just do a lot of them. It's like I could give you PowerPoints all day on how to hit a golf ball, and I haven't mastered it in 63 years or even close. There's only one way to get good at teams. And you have a couple examples. Then you analyze it, use a Pareto chart to filter causes that we need to focus on, because we can't focus on all of them, and gain agreement. Gain agreement on which ones that we want to look at first. And then start doing some improvement activity to see if we can look at some of those, eliminating some of those possible root causes. It's a way to get everybody on the same page, and it's also, I think, a really good way, to get the human part out of it. Where you're saying, oh, it's somebody did something wrong, or they weren't paying attention, or they don't care, or whatever. Which is never not the case. If the student hasn't learned, the teacher hasn't taught. Period. And that's a very difficult. It took me a long time to get my mind around that one when I owned Duraflex, because every time something happened, you're like, okay, who, right? And that's not the first question. If the student hasn't learned, the teacher hasn't taught. It provides a systematic way to brainstorm potential causes, very similar to affinity diagram, back in the define phase. Identifies areas that need more data. We gotta go get more data. And then it also locates maybe some low-hanging fruit for us. And here's the bad burgers. Here's an example, right? Here's an example of we got bad burgers. And this is something I just stole from, it looks like Wall Street Mojo. I just like it. But they do here use the 4 PM&E. Machine storage and cooking equipment. Is it clean? Is it poor maintenance of it? Is everybody following the recipe? Are they kind of winging it? They adding a little extra, whatever. For materials, are they fresh? Is the beef fresh? Is the tomatoes old? We're not using what we're prescribed. For the environment, is it too hot? Is the grill getting too hot? Is humidity too much? People sweating into the food? Maybe that adds to the bad burgers. And measurements, are we incorrect quantity of spices and things we add to it? And then personnel mishandling, unhygienic storage, insufficient training on how to cook. And usually, it comes down to, we want to try to go past the 5 who's. It's always 5 why, not 5 who. And I think Fishbone is for the 4th time I said it, I know, but I just feel very strongly that's a great way to get people's mind off of the 5 who's. So let's get into this is what we did. We're going to fly through this part of it because we just covered it in our math practice. Correlation, how strongly 2 or more variables are related, my weight and my pulse, right? Or you can pick anything you like. Pick a couple. I'm going to give you my blood pressure, I think, as we get into control charts next, and you can do the same thing. Is there a correlation between my blood pressure and my weight? Pearson's R is the one. Pearson's correlation is most popular. That's Pearson's R, the R correlation. I love it. It's a statistic measuring a linear relationship between 2 variables, and it ranges from -1 to 1. And if it's 0, there's no linear relationship. And the sign of R indicates a direction. If it's less than 0, there's a negative linear correlation. If it's greater than 0, there's a positive linear correlation. And the absolute value of R describes the strength of the relationship, where the closer we get to 1 and -1 determines the strength of the relationship. And as you guys saw, for those of you that did my weight and pulse already, it was very weak positive correlation. So it kind of looked like that, on the bottom where the 0.4 is, between the 0 and the 0.4, it looked like the Milky Way galaxy. So that tells you it's a very weak positive correlation. The R value was like 0.1 something or 0.2 something. And that's kind of like when you do the scatter plot, this is what it would look like. So as we kind of see with the salary and age, when we're close to 1, you see that nice, neat straight line, like on the left there. And correlation does not imply causation, right? If variable A is highly correlated with variable B, it doesn't necessarily mean A causes B or vice versa. It's possible that an unknown 3rd variable, C, might be causing A and B to change. For example, if ice cream sales at the beach are highly correlated with the number of shark attacks, it doesn't mean that if we increase our ice cream sales, we better watch out because there's going to be more shark attacks. They're triggered by a 3rd factor, which is the temperature in summer. And statistical significance, the correlation coefficient could be high or low by chance. It may have been calculated based on 2 small samples that don't provide good inference on the correlation. Maybe, and again, maybe salary and age and salary might be an example of that. We'd have to do more to see, what that line looks like. I just like to, like I said, I like to use it just to illustrate the tools because we only have 10 pieces of data. And we can test it as we did, as you saw, using ANOVA, where the null hypothesis is there's no correlation, and the alternative hypothesis is yes, there is. And you can use Corel to get the correlation, and we do an XY diagram. You guys did this for homework, so. And the XY diagram or scatter plot depicts the relationships between two variables, which you guys saw with both, both the homework and also the age and salary thing. And you can very quickly qualitatively assess the strength and direction of the relationship. And then to quantify it, use the R. And again, here's a repeat of the other. So we've got a perfect positive, which is the 1, moderate positive, none, which is a 0, which was 0, no correlation at all, and then moderate negative, perfect negative. And the XY helps us to spot interesting features, but it doesn't provide quantitative conclusions about the data so we can do more, understand where we should direct our improvement work. It assesses whether the association between the variables, we need to do statistical analysis to see whether the association between variables is statistically significant in order to measure the strength. That's where the R comes in. All right, so I'm going to blow through these because they're all repeats. Strong positive, weak positive. This is uncorrelated. That's a 0 on an R value. And then there might be outliers too. Doesn't follow the trend of the other data points. So we want to take a look and see if it's an outlier. What happened? And then regression analysis. So the correlation coefficient R cannot address how much does one variable changes when the other one changes. Like, this is where we can start doing some prediction. And this all assumes that we have a process that's in control, right? It's something that, is a kind of as a bell-shaped curve. It's kind of predictable, kind of like my weight data. How can we set the value of one variable to obtain a targeted value of the other? And this is why it falls into the improvement part of this certification, because now I can make improvements. So if I tweak this way, can I predict what the impact's going to be of that tweak? And the simple linear regression analysis answers those questions. So simple linear regression is what we just did. It's the line of best fit is another term for it. And it's simple because only one predictor variable is involved. There's also multiple linear regression where we have more than one predictor variable. Might be my upper and lower blood pressure and my weight, something like that. If you guys want to try that, it models the quantitative relationship between two variables. That's it. That's why it's simple. And there it is. We just, you can use the the slope function and intercept function to get A and B, right? Where there's my dependent variable, which is my salary, and A is the slope. And I can use, again, equals slope to get that number from my data, plus B, the intercept. And then sometimes you use your residuals in that equation, where over time, we see how far my data is off the line, the prediction. And we kind of compensate for that in this formula. So we have total variation, we have explained variation, and we have unexplained variation. And there's formulas for all of those. I wouldn't lose any sleep over this. I think in the data pack, that we did, the data analysis pack, it goes through and gives you all these numbers. So again, there's my red line. This is trend line here, and my predicted value is the red line. And the vertical distance SSE is the unexplained variation. And then my explained variation is between the mean, the green line, and my data point. And the total variation is from the mean to my variation. R squared measures the proportion of variability in the data that can be explained by the model, and it ranges from 0 to 1, right? There's no negatives because we're squaring it. Good catch, Dan, on that. Because I think you did it already you already did the data label on the XY diagram, but it's reflected as R squared. The higher the R squared, the better the model. And again, that all comes down to having processes that are under control. The residuals, again, nothing fancy word for how far are we off the red line. And the formula for it, line of best fit, residuals are observed versus minus predicted. And again, when we did the data analysis pack, it did that for each of the 10 ages for the salary, and it showed the salary, what it would be predicted, and it gives you that formula nicely laid out. The quality of linear regression model should be assessed by defining residuals and examining the plots. Regression equations are generated on the basis of certain assumptions. And assumptions are that the residuals are normally distributed, so we don't have a ton of outliers. The residuals are independent. The residuals have a constant variance, and the underlying population is linear. So again, really, this whole slide is, you really can take advantage of correlation and, once I know my process is under control, it's predictable, right? And in the beginning, when you're developing new processes, it's not going to be, your processes are going to be under control. It's going to take a little while to get it right, and then all of a sudden you're just taking the variation out. And at that point, now I can start making predictions. And multiple linear regression is nothing more than looking at multiple inputs, multiple X's on, so it might be my upper blood pressure, lower, and my pulse rate. How's my weight impact? How is it impacted by that, or something like that? So it's more than just one. And I'm not gonna, there's nothing on the exam on this, but a lot of times this concept of box-Cox transformation, I'm just gonna blow through this because this is not something that I've ever even thought about since I got my black belt, I don't think. But maybe, I don't know, maybe somebody on the calls used it. But basically it's like taking data and manipulating it by doing different functions, statistical functions, like squaring it or doing the log of it, and just transforming the data so it resembles a bell-shaped curve. That's all. That's all it is. It's risky. Never did it. But in case someone asks, advantages to box-Cox is linear regression is easier to visually understand and manage. Non-normal data can be changed to resemble normal data for statistical analysis. And that's kind of the beauty of it. Like if I have poll data or something like that, and I want to start to treat it and be able to predict with it, then I may use this tool. Disadvantages are difficult to understand. The transform units difficult without automation or computers. This is the data before and after. And lean. All right, let's get into the fun part just for a little bit. What time is it? 3 after. We're doing pretty good. Again, the most important part, in terms of the improve phase. And, I think I'm really excited because I'm working on, we're doing one of these improvement at Oxford. Started it yesterday, pulled the team together. So we're kind of going through what we're doing right now, and looking at different lean tools that we might be using. But here it starts with this, and being able to see these 8 weights. They don't jump out at you. Sometimes we have to do some mapping, or we have to videotape some parts of a process in order to see these things. They're largely hiding in plain sight. And generally 95% or 98% of our processes have these 8 weights. And sometimes it might take a sensei to see it. That's the whole challenge is in seeing those 8 weights. And of course, the one that the mother of all of them is the overproduction, because it causes everything else. So elimination of waste, lean concepts and tools help us improve when we have our waste identified. 5S is one way, and that's it's about standard work and visual control. It's not about mopping and cleaning and painting and all that. It's really about visual control and standard work. So that helps us. That's a huge. I think most people, when they think 5S, they think tidy and clean. Visual factory, standard work, Kaizen, and Kanban. So 5S is a systematic method to organize, order, clean, and standardize the workplace and keep it that way. Again, this presentation is standardized, by the people that allow me to certify you. So it says right in here, it's about cleaning, right? It's really about standard work and visual control. And it's summarized in 5 Japanese words, all starting with the letter S. Sort, straighten, shine, standardize, sustain. And there's a visual for it. And I always like to use, if I wanted to clean out my garage, the first step would be sort. And all that means is I take everything out of my garage, put it out in the driveway. And then I take the things, everything while it's out in the driveway, I got to make a decision of what belongs in my garage and what doesn't. And the things that don't belong in my garage, I might do what they call a red tag event, where I take those things and I might want to keep them. Like certain things I'm just going to throw out. They don't belong in there, right? Those things I put them down in the trash, have a tag sale, God forbid, have people at my house combing around, no way. Give them to somebody, regift them at Christmas, whatever. Because the only thing that's going to go back in the garage are the things that are belong in there. And then set in order, all that means is the things that are left, they have their own designated place. And this is where we see things like, labeling and color coding and shadow boards and all that kind of thing. And while I'm doing that, I might as well have an epoxy floor in my garage. So maybe I'll power wash it. Maybe I'll get all the cobwebs out of the corners. Maybe I'll paint one of the walls. Who knows what? Might as well shine it up while I'm at it. And then standardize to me means checklist. So I know PTA Oxford. I don't think Jeff Hines is on this right now, but they've done a really good job. I think Colorado's gotten started too. I know Woolworth Illinois has. So when they hear this, those guys are on second shift. They'll be hearing this probably tonight or tomorrow. But they have a checklist for each zone in the business, in the whole building, where each week there's audits that are done to make sure that everything is sorted and set in order and shined. And so standardized to me means checklist. Sustain means audit. Where basically you're taking that checklist and systematically each week someone's going through and saying, all right, yep, this is how you wanted it to be sorted and set it and shined. Yep, you did it. And usually it's a grade between 1 and 5. Atlas is really good at it too. I think I know Matthew's on this call. They've been pretty much steady with their audits and their huddles for 5S for a couple of years anyway. And here's some benefits, that are purported for doing 5S well. A lot of it's injury too. I think for Kim, that's important. Reducing injuries, potential for injuries, not waiting until injuries happen, being proactive in it. Just by making sure that everything is standardized. But these are the purported improvements for 5S. I'm not going to go through all of these. I think the garage thing, you guys have the slides. And Visual Factory. Actually, this look familiar, Dan?
Yes,
Mr.
it
Rutkowski?
does.
Does it look familiar?
It does.
I was there when they started these. These are just beautiful, right? It's like, so we have visual notice of status. Anybody can walk by any workstation anytime and know if there's variation. Are we on schedule? Are we off schedule? I think these are called visual preactors at Dan's plant, at the Ulbrich shaped wire plant. And each of the pieces of equipment have one of these boards, and it's all magnetic. And basically, you take the master schedule, and the operator is pretty much in charge, along with the schedulers, of gaining agreement on when things are going to run, how long they're going to run, when we're going to shut down for maintenance, what improvement activity is going to be on there, that kind of thing. Again, it's very visual. The one on the right is very, very simple. It's at Bakery on Main in East Hartford, Connecticut. And largely it's red and green. Red's good. Red's bad. I mean, always red bad, green good. Yellow kind of neutral always, in terms of how we think about things when we're doing visual control. And I think this was probably when they first got started with this, I imagine, but they wanted to hit 25 batches a day, and I guess they didn't hit 25 batches a day. And they do, they are cooking with gas though. They do gluten-free oatmeal, granola bars, and granola, and they sell it into Whole Foods. And they're right in East Hartford. The founder of that company just passed away, but he was such a visionary, like, because he had gluten problems, and all the food on the market when he was when he started developing these, were all tasted like cardboard. And he has things like, blueberry scone oatmeal. And I mean, I love them. They're just terrific. But anyway, this is one of their production boards. They chart their yield, number of cases and batches, QA issues, things like that. But the point is, sometimes things get lost in our computer systems. Like we think it's all nice and neat and everything's inside that box, but it's not visual and it doesn't allow us, especially when we're doing Gemba walks, to see problems maybe and look for opportunities of improvement. And that's the beauty of these things. I just saw some more at OK Industries back in December. They took me on a tour through there. I'm probably going to update the slide with theirs too. Just incredible. And so for standard work, I need to have 5S and kind of the visual factory in place. And I have to consider cycle times, assembly methods, batches. The process has to be measurable, and some more lean stuff. Kaizen, for example, I think I might have already talked to you about what that means. Kai is change. Zen is good. In reality, that symbol on the left is someone with their back to you with a whip in each hand, whacking themselves on the back with the whips. And the one on the right is a altar with an ox on it, ready to get slaughtered. So that's what those two symbols mean in Japanese. And really what it means to us is self-sacrifice for the good of all. That's what Kaizen means. But when the Americans went to Japan to learn about lean or the Toyota production system, that didn't sound too good. Flogging yourself with two whips or butchering something on a block. So they said, change is good, which is fine too. The philosophy of continuous improvement, that every process can and should be continuously evaluated and improved in terms of time. Lean is time management. If it takes us 2 hours, how do we figure out how to do it in an hour and 45 minutes? And then how do we figure out how to do an hour 20, and an hour and 10? Guys, this is the simple concept by which I was able to pretty much double in sales from 20 to 30, not double, 20 to 32 million in sales with the same 70 people. So I was able to pay them more. I was able to double their pay, actually. We were able to pay them big bonuses. We never laid anybody off. We named one of the best companies to work 5 times in Connecticut. But it all comes down to this concept of Kaizen and the Toyota production system. On the right is I think that is that Light Metals or is that Oxford? I think it's Light Metals in Southington. And this is a company with 140 employees, 150. You can see there's like 70 improvements on their A3 board. All the ones in green are ready to close. All the ones in yellow are in the process of it. There's coaches that are spelled out on the board, but there's a bunch of different ways. I don't believe that Taichi Ono and Toyota did periodic Kaizen events as a steady diet. I tried it at my company. I couldn't do enough improvements, with my team of 70 people. And the A3 process is closer to what Toyota does. And, it's constant small improvements all the time. That's all it is. They need management support. Hey, what this is? This is the Kaizen event that we had in Chicago back in July. The picture there, the guys from Albrook of Illinois are going to like that. But there's 60 A3s that were on the board and they all closed within 2 weeks. And Albrook's been doing it for 2012. I started with Chris Albrook. So 12 years, but like a machine. So basically it took a Kaizen event and turned it into 50 or 60 small improvements. And that's the team that they assembled from all over the country. And people from Mexico and Canada too pull that off. And basically it was a bottleneck of one of their machines that was impacting the schedule badly. And it's no longer a bottleneck. But it needs management support, measurable process, analysis tools, operator support. I love having what we're doing at Oxford right now. Keeping the A3 process kind of going in the background where people are engaged, they're involved, they're implementing suggestions. And then once in a while, really flexing your muscle as a lean company by being able to pull off a Kaizen event like this. Now, when these people showed up in June, there was no sitting in a conference room and introducing everybody and putting sticky notes up on the board. That was all done before anybody came. All the current condition or the define and the measure and the analyze were done starting in January or February. And people would meet on Zoom or Teams, each week. And everybody had assignments in terms of getting information and all that. And then when everybody showed up, it was just improve. And we had, we knew it was defined, it was measured, it was analyzed, and now it's a matter of improving things. And Kanban, you guys are probably familiar with that term. It means signboard. Technically, it's a pull system, right? It's to determine when to produce. It's a tool to fight overproduction. The best example is our supermarkets, where nothing gets replenished onto the shelves without something getting sold, right? It gets sold, it gets replaced. So it's the concept of use one, make one, or sell one, make one, or use one, buy one. And you can't do single piece, like one piece, all the time. But, for example, a case might be a single piece, right? So if I sell a case, I'm going to make a case. Or I'm going to sell it, like what Bakery on Main does is we sell a truckload, we make a truckload. So now when the customer says, I need a truckload, they ship it the next day. And that's why no one can compete with them. And so this is a very, very positive, very, very powerful tool. I think it's a good way to start with this is with consumables, things that you might use in the office. One of my favorite ones that everybody laughed at because I thought it was so good was at Albrecht Corporate, and it was about coffee. Like the different types of coffee that people use, and they're constantly trying to keep track of not running out of whatever cherry, whatever the heck, or I don't know, different kinds of coffee there are. And they set up a Kanban system, so largely the amount of time and energy that is spent just to make sure everybody had the coffee they wanted. And I loved it. And everybody's like, really? That's on the A3 board, the coffee? But it's a great way to teach Kanban, right? And that's why I think consumables, paper towels, coffee, anything like that is good practice, just so we start to get, because really it's about discipline. The card has to exist where the materials are. So when I'm using material, boom, there's a Kanban card. And I take the card and I turn it in, I get it bought, and I replenish exactly what, not 2 truckloads of it, but some time amount, right? If it takes me a week to get it, that means I need at least a week's worth. Probably put some wiggle room in there. I don't want to be just in time right off the beginning. But it's a really good way to control overproduction. For those of you that have done the airplanes with me, I think all the people in Colorado probably did. I'm not sure if Dan has. I know Eric has, right? Yeah, Eric's done. He did like 5 weeks of it. But again, that we use a card in between each of the 5 stations on the Lego airplanes, and that's the control over production. And again, there's a good example of it is the supermarket. So it's a ticket or signal. It's sent from the end customer up to the chain of production. You receive the card. It's a kind of a license to do some work, to make something, to deliver something, and then you put it back in place. And you notice when you go to the supermarket, even in the winter, and if you go to the soup aisle, I like chowder. It's always the same amount, whether it's the summer or the winter. They just replenish it much more quickly, more often. But there's never like, a different amount. It's always the same amount, same shelf, and really good example of Kanban. Now, Poke-OK means mistake proofing. It's a mechanism to eliminate defects as early as possible. They used to call it foolproofing, Bakayuke. That doesn't fly. Shigeo Shingo was the father, the architect of that, and that's to make our processes as mistake-proof as possible. And there's a bunch of ways to do it. One's the contact method, using shape, color, size, or any other physical attribute of the items. Constant number method, a fixed number to make sure a certain number of motions are completed, or a sequence method, a checklist to make sure all the prescribed process steps are followed, so our work instructions, our job breakdown sheets for TWI, things like that are all mistake proofing. And here's my favorite examples of mistake proofing in real life. Anybody have any idea what the mistake proofing is in the filing cabinet on the top right? Extra credit. You get like you get a green belt with like a red piece of tape on it.
Can't pull a second drawer out at the same time to avoid
Bingo.
tipping it over.
So don't fall on people, right? So it doesn't fall on people. How about the middle, the lawnmower? There's a mistake proofing device there, so people don't go to the emergency room by
Dead man switch
Getting
for
a
the
ball.
exactly right. Because they used to get a lot of people in the emergency room because they wanted to clear out under the blades while it was running and all that stuff. And
and
then
they still do that. They just hold on to the dead man switch and
try to tie it with a piece of cord or something.
yeah.
And then there's a million mistake proofing things in our cars. I don't know if it's possible to lock your keys in a car anymore. A gas gauge is a good example. The nozzles, it used to be where people would, fill up their car with diesel, or which one's worse? I forget. Got a couple engineers on this call. One of them will destroy your engine if you put the wrong one in. So now they're different diameters. You can't even fit them in there, which is good. And then there's my favorite. I would kiss the person who freaking did this, right? And that's that gas cap hanging. Because before they didn't have that little piece of plastic there. So people would go to the gas station, put the cap on top of the car, fill the gas up, drink coffee, whatever, close that lid, and then drive down the highway. Actually, when you went to 7-Eleven or anywhere, they used to sell those gas caps. And then somebody who should get a Nobel Prize put a cord on there. And to me, that's my favorite simple mistake proofing Poke-Yoke device of all time. These are just examples. In my yellow belt class that Eric took at Skill Up, I think there's like 50 or 60 of these. They're kind of fun. And guess what? You guys graduated from Improve.
Woohoo!
Woo-hoo, woo-hoo. So we got 4/5 of a coffee cup. Again, I gotta wait till I get down to Fort Myers Beach on we're getting there actually Sunday, I think, because we're going to Orlando tomorrow for a little while, see my brother. But once I get the Wi-Fi set up, I think my wife's gonna pick up the box or whatever we have to do, then I'll have a better idea. What I'm saying is I'm afraid I might not be able to do it for Monday. I might not be, I'm not technically advanced. Neither of us, I'm 63 and the kids aren't coming, so. But anyway, thank you guys for coming today. If you need help, to get the homework caught up, please reach out to me because I do feel like I'd like you to try it. I'll send you a recording and just a little bit of homework. Shouldn't take very long. Just messing with that weight and pulse data again, with regression and if you want to do residuals, go ahead. So have a great night, you people.
Thanks, you too.
Thanks. Have a good night.
Thank you, Bill. Have a great one.
You too.